So now we're going to look at arrays. And so before we get into strings, and also so we can avoid using ints everywhere, I want to make an array and sort of do some operations on an array of structures. And so this will hopefully help you to really understand how arrays work, because integers are a bit simple. And so we'll take a bit more complex, and hopefully it sort of cements it a bit more. So for those of you that don't remember what a structure is, we talked about them briefly before. They are a collection of variables, and each variable has a data type. It can be another structure if you want. A collection of variables in memory that all are together in sequence in a block. And so if we have an array of structures, it's just an array, like a continuous array of these blocks in memory, right? And so let's create a structure, struct my struct, and we'll just define here what actually is inside the structure. And so we'll just put two ints. We'll put a foo and we'll put a bar, right? So now we know from just, we're sort of smart people, we know an integer is 4 bytes. Okay, cool, the size of my structure is going to be 8 bytes. Easy. So we'll go into main, and let's say we want to create an array of this. So the data type of the array is a struct, my struct. And then let's say, okay, cool, we want to make, we'll call it my struct array. So this is the actual instance or the variable name, the identifier for my array. And then we have to give it a length. So we'll give it a length of 5, right? Now, if we just go and do this, and if I make this and run this in GDB and print, we'll go to break 14, print my struct array, we'll see here we have these like random garbage values. And so this is because all the compiler is doing is taking the size of this element, the number of elements, and allocating the size of each element times by the number of elements in memory. It doesn't care, because we haven't told it to, if the contents of that memory is actually 0 or not. And in this case, you can see here it's not. We're lucky the first 2 items were, but if we want to guarantee that our array is 0 when we begin, which is usually good practice, we should 0 it out using this notation. So if we then do the same thing again, we'll go run GDB, we'll break on 14, and we'll print my struct array. And now we have it all zeroed out. Similarly, we could initialize our array to have some sort of values. Now, the initialization of an array takes the syntax of like init vals of 0 index, 1 index, blah blah blah. Like it's a list of values with commas between them. But because we have a struct inside of each one, we actually need to use another squiggly brackets, because inside here we can specify what we want to initialize. So foo bar equals 3. And then for instance, in the second item, we just want to say, oh yeah, cool, we'll just set bar, and we'll set that equal to 5 or something. And the ones that we don't set will automatically get zeroed. So as soon as you initialize something in your array, the rest of it gets zeroed out. So if we make this again, GDB it, break 14, and now we print, we can see that we have initialized, yep, these 2 ones here, 5 was also initialized, and the rest of them was zeroed out. We're great. Now, we can think about this. So we want to know how much memory this array is taking up. And we've calculated, yeah, cool, my struct is 8 bytes because it's 2 integers and we have 5 of them, so we're going to say 40, right? We can double check this. Well, let's do print f on size of struct. Let's run this. And we'll see this, each one's 8 bytes, right? Makes sense. Now, if we want to look at size of array, struct, so this is just my struct array. We can see that it's 40, and this is because we have a length of 5, and it's 8 of them each. So now we can say, okay, cool. we have this in memory. Let's do some stuff with it. Like let's start setting values. And so we want to say, let's set bar of the 4th index. So therefore we need to get the 4th value, or the 4th index being the last value, because we have a length of 5. So we then say my struct array 4, and this will return to us the structure struct my struct at the end of our array. And we can now use the dot notation, because we now have this structure, to access its members. So we can then go and set bar equal to 10. And if we then we make this and we debug it, and we'll break on 19 and print my struct array, we'll now see that the final one has been set to 10. Right? So this is the setting, and reading it is exactly the same. So we could say my struct array 3rd, and now I want to say third dot bar equals my struct array 0 dot foo times by my struct array 0 dot bar. Easy. And so if we print my struct array again, we can see that in the 3rd one here, in bar, we have the contents of the first one multiplied together stored. So there we have access to write, and then here we have access to read. So it's pretty simple. So then really, let's talk about, now look at strings. Strings are the exact same thing, but they have a terminating character, and the data type is a char. Right? Because it's an ASCII string, therefore it's only got a small range of characters, and so there's no way you're going to need to store 270, because there's no ASCII code for 270. So we'll say character, and the simple way of doing it is to say character my string, and we'll put in an empty bracket so that we don't have to count the length we need. And we'll say this is my string. Easy, like that. Now if we actually go and count this, we'll see that you have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now if we go print string size, we'll see it's 18, because there's that termination character in the end. And so we can see this even more clearly if we debug the code, and we look here and we print my string. My string 17. Come on. So we'll see here, because it's the length 18th, so this is the last item, and here we have that termination character. And so this is very important. This is what makes this string a string, right? So that should hopefully sort of explain strings. There are a lot of operations that can be done on them. You need to be wary though, that when you're dealing with arrays, you can't just copy them over. Like you can't just say, create a new string and say, like my string, and make it my string, oh wait, hold on, char second string equals my string, right? Because it can't just do this. My string itself is an array, but like the reference here is just telling you where it starts in memory. It's a memory address, really. It's a pointer, actually, but we'll get onto this later. And so what you're saying here, or if you, for instance, had a my string of length 18, it will give you the same error, because you're trying to say here, I want to set a memory address into my array of characters. So if you wanted to actually do this correctly, you would then have to create an array, which we know to be the right length. And then we can use functions in the string standard library. So include string.h, and we get access to functions like string copy. And if we look at the manual pages for string copy, it says the string copy function copies a string pointed to by source, so this one, including the termination null byte to the buffer pointed to by destination. So what we want to do is we want to put, okay, we want second string in here, and then my string in here. And then this is going to copy in memory the contents, like actually make a duplicate copy of it and not just point to it. Then we can print this out. So we'll print second string. And you can see here now we've created a copy of it. But you need to, for instance, with arrays, you can't just allocate, hey, I want this whole array to be equal to that whole array, because the array elements in the array itself are referenced by memory addresses. And so if you want to actually copy the whole array, you need to use these functions such as string copy, or if you want to have a more general purpose one, you would use memcopy. And so memcopy is just used for copying one block of memory from here into here, and this is the size of it. So if I wanted to copy my entire struct array, I would say, yep, put it here, this is it, and I know that it's 40 bytes. So I can do size of my struct thing, my struct array. So hopefully this all makes sense.